Welcome to AI World TV, your go-to destination for everything artificial intelligence. Discover the captivating landscape of AI, where advanced technology finds real-life application. Subscribe to AI World TV for webzine articles, reports, podcasts, videos, live events, and latest trends. Hear from top industry leaders and discover how AI is transforming industries and our daily lives.
When you think about adopting a new technology, I feel like the default mental model is usually just buying a tool, like a hammer, right?
Right. You buy it, you put it in a toolbox, and it just sits there.
Exactly. It sits there completely inert until you physically pick it up, apply your own effort, and, decide what you're going to hit with it.
Yeah, a tool is entirely dependent on human intent and human supervision, really, to generate any actual value.
But then, you have something like electricity. You don't really use electricity the way you use a hammer. It's just this invisible infrastructure humming in the walls, right?
Totally. It powers everything you do, whether you're consciously directing it or not.
Yeah, and that transition from a discrete tool you pick up to an ambient grid that runs your entire operation, that is exactly where we find ourselves today.
It really is.
And you can see the definitive proof of this shift in the AI World Journal's mid-year 2026 report, which, for you listening, just dropped today, July 11th, 2026.
Hot off the presses.
Seriously. So we are pulling directly from that massive release for you today, along with a roundup of their latest industry headlines, because our mission is to figure out how this transition actually happened in just the last 6 months. How did AI become the literal operating system of the global economy? So, okay, let's unpack this.
Well, the overarching theme of this report, and it's a big one, is this fundamental change in how success is measured.
Right.
Even just, year or two ago, enterprise AI was evaluated on its innovation potential.
Yeah, like look at this cool pilot program or check out this novel text we generated.
Exactly, the proof of concept demos.
Yeah.
But the metric for success today has shifted entirely to hard ROI.
Return on investment?
Yes. We are talking about verifiable cost reduction and net new revenue generation.
Mm-hmm.
If an AI deployment isn't operating autonomously enough to actually move the financial needle,
then what? The market just dumps it.
the market considers it a complete failure.
Yeah.
The experimental phase is over.
Wow. Which means the underlying architecture, the brain of these systems, had to undergo a pretty radical upgrade to deliver that kind of autonomy.
Oh, absolutely.
Because we are way past the era of linear prompting now. The report shows the defining architectural shift of 2026 is the deployment of agentic AI.
Right, and we really need to unpack how an agent differs mechanically from a standard language model.
Yeah, because people still confuse the two.
They do. A standard model, just predicts the next word based on a prompt. But an agentic system uses that language model as a reasoning engine to drive a continuous loop.
A loop. So it's not just a one-and-done answer.
Exactly. It takes a high-level goal, breaks it down into sequential subtasks, assigns those tasks to specialized tools or other agents, reviews its own output.
Right, it checks its own work.
It does. It corrects its own errors until the overarching goal is met.
That is wild. The report actually highlights organizations deploying these multi-agent systems for things like end-to-end software development and real-time financial fraud analysis.
It's everywhere.
But I think the customer support applications really illustrate the mechanics best, because we aren't looking at a bot that just pattern matches your question and spits out, an FAQ link.
Right, those days are gone.
These systems are resolving Tier 2 and Tier 3 tickets. They're securely accessing a company's back-end database, analyzing a user's server logs, finding the exact line of code causing a conflict, and pushing a patch, with zero human escalation.
They're acting as autonomous digital workforces.
Yeah. And I was trying to visualize how this orchestration actually happens on the back end for you guys. And it's a lot like a digital general contractor.
I like that analogy.
Right. But the key isn't just that the platform hires a plumber and an electrician. It's that the agent orchestration platform translates your high-level blueprint into a shared language. So the data analysis agent and the coding agent can actively argue with each other.
Yes, that internal debate mechanism.
Yeah, they simulate the build, identify conflicts like the plumber and electrician realizing their pipes and wires are going to cross in the same wall, and they resolve those conflicts before executing a single line of actual code.
And that debate is exactly what creates the reliability required for that hard ROI we talked about. You're managing the final outcome, not babysitting the inputs anymore.
Right.
But achieving this level of agentic collaboration has actually driven a deeply counterintuitive trend in model development.
Oh, the model sizes. Yeah, I found that section of the report fascinating because the assumption has always been, parameter count equals intelligence. The bigger, the better.
Right.
So why shrink the model if you are trying to do more complex agentic reasoning?
Well, because you don't need the equivalent of a PhD in 16th century poetry to process a complex logistics invoice.
Right, that makes sense.
Or to route a database query by utilizing techniques like parameter pruning and knowledge distillation.
Well, which is basically what taking a massive model and teaching a smaller one.
Exactly. Using a massive model to teach a much smaller model only the specific behaviors required for a narrow task. And by doing that, organizations are unlocking three massive advantages. First, the infrastructure cost just plummets.
Naturally.
Second, data privacy becomes absolute because you can run an SLM, a small language model, locally on your own enterprise server cluster, meaning your proprietary corporate data never crosses the open internet to some third-party cloud provider.
Oh, that's huge for enterprise. And third is the latency, right? When you strip out the cloud round trip, you just eliminate the lag entirely.
True real-time processing. And this enterprise trend is bleeding directly into consumer technology.
The on-device AI boom.
Exactly. This push for highly optimized, smaller models is the exact mechanism driving this explosion. Your smartphone, your personal computer, the internal systems in your car, they're all running these complex inference engines locally now.
On their own neural processing units.
Yeah, they don't even require an active connection to the cloud to perform reasoning tasks anymore.
But, that local processing power doesn't just materialize out of thin air. Here's where it gets really interesting, because if we are running autonomous swarms of agents on corporate servers and simultaneously deploying native AI onto billions of edge devices, the physical manufacturing and energy required to sustain that compute load must be absolutely staggering.
It is. It forces us to look at the physical bottleneck.
Yeah.
The physical infrastructure is the absolute ceiling on AI's growth right now. The report breaks down the capital expenditures, and the scale is just unprecedented.
It's mind-blowing. Hyperscale data centers are drawing so much power and generating so much heat that traditional HVAC cooling is entirely obsolete.
It can't keep up.
No, they're engineering advanced liquid cooling systems, like circulating engineered fluids directly over the chip clusters just to prevent the silicon from physically melting under the load.
What's fascinating here is that the power required to run the chips in those cooling systems is literally breaking the grid. The jaw-dropping detail in the journal's analysis is that tech giants are no longer just buying renewable energy credits to, look green.
Right. The PR moves are over.
They are actively converging with the energy sector. They are directly funding the construction of nuclear microreactors and advanced geothermal plants.
Because wind and solar just can't do it.
They cannot solve the baseload problem for a 500-megawatt AI training cluster. Renewable energy has intermittency issues. The sun sets, the wind stops.
Right. And AI data centers need what? 100% stable, uninterrupted power?
24 hours a day, 7 days a week. Nuclear is one of the only carbon-free ways to guarantee that baseline.
So these tech companies are essentially being forced to become utility companies just to keep their own models running.
Essentially, yes.
And this insatiable demand for hardware and energy has triggered an absolute war among the suppliers.
Oh, a massive war. The supply chain was heavily monopolized for a long time, heavily reliant on NVIDIA for those specialized GPUs.
Yeah, NVIDIA was the only game in town.
But that monopoly is fracturing under the sheer weight of global demand. Hyperscalers, the massive cloud providers, are now designing and fabricating their own custom silicon from scratch just to bypass the bottleneck.
And you can see the intensity of this hardware war in the headlines accompanying the report today. AMD is mounting a landmark challenge to NVIDIA's dominance through a massive new supply deal with OpenAI.
Yep.
Meanwhile, Apple is actively suing OpenAI over alleged stolen trade secrets related to model optimization. The corporate gloves are completely off.
Because controlling the hardware stack and the proprietary training data is an existential requirement for these companies now. If you don't have it, you die.
Wow.
And this panic extends well beyond the corporate layer. Governments are analyzing these exact same data center bottlenecks and realizing that advanced semiconductors are basically the new oil.
Right.
If a nation does not control its own chip supply and its own compute infrastructure, it effectively does not have a modern economy.
Which perfectly explains why the report highlights governments heavily subsidizing domestic semiconductor fabrication plants. They are pouring billions into building fabs on their own soil to insulate themselves from geopolitical supply chain shocks.
Exactly. So we have this situation where the digital architecture has upgraded to autonomous agents, and the physical architecture is demanding nuclear power and sovereign semiconductor manufacturing.
It's a perfect storm.
It really is. And when you combine that upgraded brain with that level of subsidized brawn, the technology finally breaches the digital barrier. AI is no longer confined to generating text or images. It is actively manipulating physical reality.
And then the impact on the physical sciences in just the first half of 2026 is phenomenal. The report details how generative AI is being used in drug discovery, specifically.
You are listening to the AI World Podcast, your trusted source for the latest innovations, insights, and trends in artificial intelligence, blockchain, fintech, and decentralized technologies. Each episode features expert interviews, engaging discussions, and in-depth analysis of how AI transforms industries worldwide. Stay ahead of the curve with the latest articles and exclusive reports from the AI World Journal, covering everything from emerging technologies to industry breakthroughs. For more news, global events, and access to AI World Society circle gatherings, visit us at aiworld.tv. Don't forget to subscribe to stay informed, stay connected, and be part of the AI revolution with AI World Lounge. Thank you for listening.
Designing entirely novel protein structures.
Yeah, the mechanism behind this is just a brilliant translation of language model architecture.
How so?
Well, a protein's function in the human body is entirely dictated by its three-dimensional folded shape.
Okay.
Historically, figuring out how a linear chain of amino acids would fold into a 3D structure took months, or even years of trial and error using X-ray crystallography in a lab.
Just incredibly tedious work.
Extremely.
Yeah.
But AI models learn to treat amino acid sequences like a language, treating the chemical bonds like grammar and the final 3D shape as the meaning of the sentence.
Oh, wow. So instead of physically testing the proteins, the AI simply translates the chemical language and predicts the exact physical shape in seconds.
Yes, cutting pharmaceutical R&D timelines by literal years.
That is incredible. And we are seeing the exact same mechanism applied to material science, right? The report mentioned batteries.
AI models are simulating millions of atomic arrangements in latent space overnight, just to predict highly stable crystalline structures for next-generation solid-state batteries.
So they're finding the perfect chemical compositions for energy storage without ever mixing a single chemical in a physical lab. And the regulatory bodies are actually adapting to this speed, which is shocking. The FDA has formalized its classification for software as a medical device. SAMD.
Right, the SAMD pathways.
Yeah, they've created these streamlined adaptive approval pathways that allow AI diagnostic tools to continuously update their localized models without needing a completely new approval process every single time the algorithm learns something new from a patient scan.
It is a really rare example of regulatory frameworks accelerating innovation rather than throttling it.
Truly. But the physical world integration goes way beyond medicine and batteries. I really want to look at embodied AI.
Oh, yes.
The report details the rapid deployment of vision language action models, VLA models.
This is a crucial leap because a traditional language model, just outputs a string of text. But a VLA model takes in raw visual data from a camera, processes the semantic meaning of that scene, and outputs a physical coordinate.
Like a motor torque command.
Exactly, a physical action.
So it translates pixels into physical movement. If a humanoid robot looks at a messy warehouse floor, the VLA model identifies a scattered palette, understands the concept of cleanup, calculates the precise spatial geometry of the boxes, and sends the exact electrical currents to its servos to physically stack them.
Yes. It's general-purpose reasoning applied to physical space.
Which has totally moved humanoid robotics out of the R&D labs and directly into manufacturing, logistics, elder care facilities. It's everywhere.
It's moving incredibly fast.
But the business model around this is what's wild to me. The report outlines the explosion of robotics as a service, or RODIAS.
Right.
Companies aren't buying a fleet of humanoid robots. They are leasing them. You essentially call an agency and rent a squad of robotic temps for like a 6-month warehouse contract.
Yep.
I read the section analyzing the investor reaction to this, noting that funding for thin wrappers has completely dried up in favor of these heavy physical deployments. But honestly, I'm struggling to see why an investor would abandon a low-overhead software startup for a wildly expensive hardware-heavy robotic temp agency.
Well, because a low-overhead software app, a thin wrapper that simply puts a sleek user interface on top of someone else's foundation model, it has zero defensible moat.
Just none at all.
None. As the foundational models get cheaper and more capable, they simply absorb the functionality of those wrappers natively. Investors realize that anyone can clone a software UI over a weekend.
Oh, I see.
But if you have integrated your AI into a proprietary fleet of physical robots, or if your model is trained on a closed loop of physical warehouse data that no one else has access to, you have a monopoly on that specific workflow.
Because the physical data is the moat.
Exactly. Investors are demanding proprietary data vaults and physical hardware integration because that cannot be replicated by a competitor just tweaking a prompt.
That makes total sense now. But, you cannot undergo a transition, this massive renting robotic temps, building nuclear data centers, orchestrating swarms of agents without triggering a massive societal immune response.
Oh, absolutely.
The friction is palpable right now, and the stakes have moved from technology blogs straight into national security.
The era of AI versus AI is fully underway,
Yeah.
particularly in the realm of cybersecurity.
Yeah.
We are no longer dealing with static viruses that just execute a set of pre-programmed commands. Hackers are deploying polymorphic malware.
Which are, what, autonomous offensive agents?
Exactly. Agents that actively probe a network, encounter a firewall, and rewrite their own code on the fly to find a way around it.
That's terrifying.
They are utilizing prompt injection attacks to subtly manipulate enterprise agents into handing over sensitive database access.
So if the malware can reason and adapt in real time, a human security operations center has literally no chance of keeping up.
None. Human reaction time is completely obsolete in this context. It is machine speed warfare. The only defense is deploying autonomous defensive agents that patrol the network, analyze behavioral anomalies in real time, and isolate compromised subnets in milliseconds.
The cyber reality is a huge part of why governments are pushing so hard for sovereign AI, right?
Yes.
Because if the defense of your national infrastructure relies on machine speed AI, you just cannot depend on a model hosted on a server in another country. The report highlights Canada's AI for All strategy as a prime example of this.
It's a great example.
They are treating AI compute and localized foundation models as critical national infrastructure, like on par with their highway or water systems, ensuring they aren't entirely beholden to Silicon Valley for their own digital survival.
And that friction at the nation-state level is mirrored perfectly by the friction happening on the ground level in society.
Completely. The headline roundup from the AI World Journal paints a picture of widespread localized pushback across the board. Just impartially looking at the news, it's everywhere. In San Francisco, protesters physically marched on the headquarters of OpenAI and Google DeepMind, demanding a complete halt to AI development, citing displacement and safety concerns.
Yep.
In academia, the University of Chicago Law School instituted a strict ban on phones and laptops for all first-year students, which is a deliberate strategy to force students to develop original legal reasoning skills without relying on digital co-pilots.
We are seeing the exact same turbulence in the corporate and political spheres, too.
Yeah, Meta faced such intense public backlash over a newly rolled out AI image feature that they were forced to pull it from the platform entirely within days. And politically, Donald Trump made headlines by stating he wants to rename the technology entirely. He argued that he doesn't like anything that's artificial and framed the push for a rebrand as pure genius.
Right.
The pushback is coming from every conceivable angle: labor, academia, consumer markets, politics.
But if we connect this to the bigger picture, this friction is not just noise. It is the necessary catalyst for establishing entirely new corporate and regulatory structures. Companies are realizing they can no longer treat societal pushback as a minor PR issue. It is an existential threat to their deployment.
Oh, because it can derail the whole product.
Exactly. We are seeing standard VP-level roles for AI ethicists integrated directly into the C-suite now. Their mandate is essentially compliance and risk mitigation, navigating this exact societal turbulence before it derails a product launch.
Because the regulatory environment is solidifying right alongside the technology.
Exactly. The theoretical debates about copyright, whether an AI can train on scraped data, those are actively becoming enforceable regulatory frameworks. We are seeing mandated cybersecurity audits for any AI system interfacing with critical infrastructure.
So the Wild West phase of unchecked deployment is basically closing.
And the regulated utility phase is beginning.
It is genuinely staggering to look at the compression of this timeline. I mean, in just 6 months, we went from tweaking prompts to orchestrating swarms of digital contractors. Tech giants are funding nuclear reactors to win a global hardware war. We're modeling solid-state batteries in latent space, deploying leased humanoid robots, and fighting machine-speed cyber wars.
It is the most accelerated period of technological integration in human history, without question.
So what does this all mean? The report highlights a massive corporate push for upskilling the human workforce to manage these new autonomous agents. But this brings up a hidden paradox that I think is the most critical thought we can leave you with today.
The big one.
If we are successfully offshoring our routine coding, our basic financial analysis, and our entry-level problem solving to these autonomous agent swarms, how does the next generation of humans actually learn the foundational skills?
Right, because the entire architecture of human knowledge transfer relies on the apprenticeship model. You build intuition, judgment, and expertise by doing the tedious routine work first.
You have to struggle through building a basic financial spreadsheet to understand the mechanics of the market.
Exactly.
If the AI agents execute all the entry-level work flawlessly, where do the future human experts come from? How can a human manager oversee an AI doing complex, multivariable financial modeling if that human never had to learn the basics themselves?
It is a generational knowledge gap.
Right.
We are building systems that can execute flawlessly, but we risk amputating the very process by which humans learn to understand those systems.
We have managed to build the ultimate invisible power grid, but we might be slowly forgetting how the electricity actually works.
Yeah.
Well, thank you for joining us for this deep dive into the AI World Journal's mid-year report. Keep questioning the rapidly changing systems around you, look closely at the invisible infrastructure powering your day, and we will catch you next time as we continue to untangle the technologies rewriting our reality.
The future of artificial intelligence is unfolding, and it's happening at AI World Week, the flagship global event for innovation, collaboration, and transformation. This flagship global AI event is designed to connect visionary leaders, trailblazing entrepreneurs, and influential thinkers to explore the endless possibilities of AI. Experience groundbreaking technology that redefines industries and inspires progress. Join thought-provoking discussions on ethical AI, digital equity, and the transformative role of technology in our world. Build meaningful connections that catalyze innovation and drive impact. AI World Week is powered by AI World Society, a global movement dedicated to advancing AI responsibly and ensuring it serves humanity. Together, we're shaping a smarter, more inclusive, and equitable future. Continue your journey beyond the event with the AI World Journal, offering expert insights, in-depth analysis, and the latest trends shaping the AI landscape. This is your opportunity to lead, to innovate, and to transform the world with AI. AI World Week. We invite you to join us and embrace the AI revolution.